All right, guys, today in Gen Chem, we are going to do some more with the mole. I just wanted to remind you of the concept of the mole before we get into things that we're going to do today. So, this is a page that is not in your workbook. So, I have attached the page to this module so you can have this page. So, if you need to, it's in the page in the module, you can have it. So, here's the idea of the mole. It turns out the atomic mass of an element in grams contains 6.022 or 6.02 times 10 to 23 molecules or atoms, or a mole of atoms. The molecular mass, this is what we're going to do today. We're going to learn how to find the molecular mass. So the molecular mass of a compound in grams is the molar mass. It also contains 6.022 times 10 to the 23 molecules. Okay, so today we're going to learn how to calculate molecular mass and molar mass. Okay, so we can go back and forth using this relationship between mass in grams and moles and the amount of molecules that we have using these different conversions. Okay, and we're going to use these conversions a lot in the next coming days. And we'll practice it. I know it looks kind of like a mess right now, but we'll practice it a lot in a day or two. But I want to talk about molar mass. So last time we talked about the atomic mass. So for example, let's look at our periodic table. We're going to look at aluminum really quick. So if I look at aluminum, I said it was 26.98 atomic mass units. So where did I get that 26.98? So let's look at aluminum really quick. Here, I don't want this on here. So if I look at aluminum, the mass that I have on here is 26.98. Now that's in atomic mass units. Now if I convert those atomic mass units and make them grams, 26.98 grams of aluminum will give me a mole of aluminum. It will give me 6.02 times 10 to the 23 atoms of aluminum. Okay, so that is the concept of the mole. So we're getting these masses right off of the periodic table. So today we're going to work on finding the molecular mass of a compound. So to do that, we simply add the individual atomic masses of each element in the compound. For example, water, H2O, we have 2 hydrogens and 1 oxygen in that compound. So that means we're going to add up 2 hydrogens and 1 oxygen. So we're going to round to the nearest tenth here. So let's look at hydrogen and let's look at oxygen. So hydrogen is 1.008, which will round to 1.0, and oxygen is 15.999, which to the 10th, that 9 tells me to round up to 16.0. So when I look at that, I'm going to grab 2 times 1 for the hydrogens, and I'm going to grab 16.0 for the oxygen, and add them together. That will give me a molecular mass of 18.0 atomic mass units. So if I want a mole of water, I'm going to make that grams. 18 grams of water will give me a mole, or 6.022 times 10 to the 23 molecules of water. That's just a little bit more than a tablespoon of water. Okay, so we're going to practice with a few more. I want to find the molecular mass of the following. So let's start with chlorine. Chlorine is diatomic, so there are 2 atoms of chlorine that stick together. So let's look at chlorine here on our periodic table. So if I look at chlorine 35.45, that 5 is going to tell that 4 to round up to a 5. So we're going to call that 35.5 grams. Okay, so 35.5, and I've got 2 of them, so I've got to multiply it by 5. Or sorry, by 2. I'm misspeaking all the time. So 35.5 times 2 will give me 71, right? Let's do that really quick. 35.5 times 2, 71 grams per mole. 71.0 grams per mole for chlorine. Okay, so let's look at potassium hydroxide. We've got one potassium in here, one oxygen, and one hydrogen. So we're going to look at all of these. So let's look at potassium first. Potassium, 39.09. That 9 in the hundredths place tells me to round up in the tenths place to 39.1. Okay, so potassium is 39.1. Now we're going to look at the oxygen. Oxygen we've already looked at before. Oxygen is 15.999. That 9 in the hundredths place tells that 9 in the tenths place to round up, which means we have to round up to 16.0. Okay, so 16.0. And hydrogen, I'm writing these to the hundredths out of habit. Hydrogen is 1.00, so that 0 in the hundredths place tells me to leave that 0 in the tenths place alone. So 1.0. So if we add these all up together, we're going to just add them up. So 39.1 plus 16 plus 1 gives me a molecular mass of 56.1 grams per mole of potassium hydroxide. Okay, let's look at example number 3. We have iron 3 bromide. So we have one iron atom. Let's look at iron really quick. Iron is 55.84. That 4 tells us to leave that alone. So we're going to call that 55.8 for the iron. And bromine, let's look at bromine really quick. Bromine, do you guys see it? 79.90. That 0 tells me to leave that 9 alone, so I'm going to call that 79.9. Now the thing is, we've got 3 of these bromines, so I need to multiply my 79.9 by 3. So when I do this, I'm going to have 55.8 plus 79.9 times 3. Now remember your order of operations. You might want to put a parentheses here, okay, to help you. This will give us a molar mass of 295.5 grams per mole of iron 3 bromide. Okay, let's do this next one. We've got carbon dichloride, difluoride. So if we look at this, we've got one carbon, we've got 2 chlorines. So let's do the chlorines by 2, and we've got 2 fluorines. So we're going to multiply our fluorines by 2. So let's look on the periodic table and see what we've got. So carbon, 12.01. That 1 tells me to leave that 0 in the tenths place alone, so 12.0. Chlorine, we've already looked up before, didn't we? Over here, 35.5. Fluorine, let's see. Fluorine, 18.99. That will round up to 19.0, right? That 9 tells the other 9 to round up, which tells the 18 to round up to 19. So 19.0. We are going to add all of these up. So 12 plus 2 times 35.5 plus 2 times 19. That gives me a molecular mass of 121.0 grams per mole of carbon dichlorodiafluoride. Okay? All right. Now, here's a new one. Do you see how this one actually has parentheses in it? What does that mean? It's just like math, only instead of putting our coefficient in front of the parentheses like we do in math, in chemistry we put our coefficient at the end. So that means this 2 multiplies everything in that parenthesis. That means I have 2 oxygens and I also have 2 hydrogens. Okay, so let's figure this one out. I've got 1 magnesium and I've got 2 oxygens and I've got 2 hydrogens. So I need to find these masses. We've already dealt with oxygen a couple times. It's 16.0, and we've already dealt with hydrogen a couple times. It's 1.0. So let's look up magnesium. Magnesium, 24.305. So we're going to call that to the 10th place 24.3. Okay, we're going to add all of these up. Okay, 24.3 plus 2 times 16 plus 2 times 1. That gives us 58.3. 58.3 grams per mole for the magnesium hydroxide. Okay, now you guys should have a pretty good idea of how to do this. So I want you guys to do the next couple on your own. Try 6 and 7 by yourself. Pause the video and take a minute and do that, and we'll check in a sec. Okay, you ready to check? So sulfur, I've got 1 sulfur and I've got 2 oxygens in sulfur dioxide. So I'm going to set that up. We've already got a good feel for oxygen. It's 16. Let's look at sulfur. Sulfur, 32.06. That 6 tells me to round up. So I'm going to call that 32.1. 32.1. So here we go. Let's add that up. 32.1 plus 2 times 16 gives me 64.1. 64.1 grams per mole for sulfur dioxide. All right. Did these parentheses scare you? Ooh, I see a typo here. It shouldn't just be NH4. It should be, let's see if I can edit this. Maybe not. It should have a 2 there. So let me edit this really quick. Ammonium sulfate. Ammonium sulfate. Okay, so let's go with that edit. So how many nitrogens do we have? 2 times 1 gives me 2. How many hydrogens do I have? 2 times 4 gives me 8. So I'm going to need to multiply that. Sulfur, I have 1, and oxygen, I have 4. Okay, so oxygen is 16. We've already done that. Sulfur in the last one, we did that too. So it's 32.1. 32.1. Hydrogen we've done as well. It's 1.0. We have not done nitrogen yet, though. So let's do nitrogen. Nitrogen, 14.007. So that 0 tells us to leave it alone. So 14.0. 14.0. We're going to add all of these together. So 2 times 14 plus 8 times 1 plus 32.1 plus 4 times 16. That gives us a molar mass of 132.1 grams per mole. I'm sorry if you got that wrong because the typo that I didn't fix before. All right, let's try these next couple ones. Gallium sulfite. So gallium, let's see, this would be gallium 3 sulfite. How many galliums do we have here? We've got 2 of them, right? So I need to look up gallium and I need to multiply that by 2. 3 times 1 gives me 3 sulfurs. 3 times 3 gives me 9 oxygens. So oxygen is 16.0. We've already done that. Sulfur is 32.1. Let's look up gallium. Okay, gallium is right here. 69.72. So 69.7 is where it's going to round to the 10th. 69.7. So we're going to add all of these up. So 2 times 69.7, right? Plus 3 times 32.1 plus 9 times 16. That will give us a molar mass of 379.7 grams per mole for the gallium 3 sulfite. Okay, how'd you do? All right, let's go to number 9, carbon dioxide. Di means, we've done this before. Di means 2. So we have carbon and 2 oxygens. Okay, so that's the formula. We have 1 carbon and 2 oxygens. So carbon, we've done that, 12.0. Oxygen, we need to multiply it by 2, and we've got 16.0. So we're going to add that together. So 12 plus 16 times 2 gives us 44 grams per mole. Okay, barium nitrate. Nitrate is one of our polyatomics. It's an NO3 and it has a -1 charge. Barium, let's look at barium. Barium is right here. It's in our second column, so it's going to have a +2 charge. And it has a mass of 137.3. So let's do this. Barium is a +2, and it's 137.3. Did I get that? Yep, 137.3. So if this is a -1, this nitrate, and this is a +2, how many of each do I need to get the charges to add up to 0? Did you say 1 barium and 2 nitrates? +2 plus 2 -1s will equal 0. So the formula here is this. Did you get that? Okay, so let's look at it. We've got 1 barium. We've got 2 nitrogens, and we've got 6 oxygens. So barium we've already looked up. It's 137.3. Nitrogen we used in number 7. Nitrogen is 14.0 and oxygen is 16.0. We're going to add all of that up. Okay, so 137.3 plus 2 times 14 plus 6 times 16. We get a molar mass of 261.3 grams per mole for the barium nitrate. Okay, and last but not least for our example, we have sodium carbonate. So let's look at sodium really quick. Sodium is in our very first column. It has a +1 charge. And to the 10th, 22.99. That's going to round up to 23.0. So sodium +1, 22.99. So that's really, let me erase that. That's going to round up to 23.0. 23.0. Carbonate is on our polyatomic chart. If you don't have one handy, carbonate is CO3 -2. Okay, so how am I going to have a +1 matched up with a -2 and get it to equal 0? What ratio do I need? Think about that. If you said 2 sodiums and 1 carbonate group, you're right. So I'm going to need to multiply my sodiums by 2 because I need 2 of them. I have 1 carbon. My carbon's mass is 12.0, and I've got 3 oxygens. Let's write this formula here. Na2CO3. And I'm going to have 3 oxygens. Okay, so I'm going to add all that up together. So 23 times 2 plus 12 plus 3 times 16. That will give me a molar mass of 106.0 grams per mole for sodium carbonate. All right, so your homework assignment is to calculate molecular masses, and some of them I've given you words of formulas, words of chemical compounds, and you're going to have to come up with the formulas and then also create the molar mass. All right, have a great day. We'll see you in class, and we'll actually start dealing molar mass and moles next time. See you. Bye.